So this is our AP Chemistry Chapter 3 lesson video part 3. And today we're going to focus on section 3.5. And I know you're sick of hearing about it, but you should have already learned this in honors chemistry. So again, hopefully this is just a review. So we're going to focus on empirical formulas from Analyses. So an empirical formula is the lowest whole number ratio of elements in a chemical formula. So molecular formula is the real formula that shows the actual number and types of atoms. The empirical formula has been reduced. The ratio of the number of moles of each element in a compound gives the subscripts in the compound's empirical formula. So C4H8 can be reduced to CO2. So that would be the empirical formula of C4H8. So when given percentages, assume 100 grams so the percentages can be grams. So remember we talked about we would just change the percentage to grams. If they go ahead and give you grams, you just use the grams. Then divide each massive element by its molar mass, so that way we can change it to moles. Again, if they already give you moles, you can go ahead and move past this step. Then divide all the answers by the lowest number to get subscripts, and then if you get a 0.5, we multiply all our numbers by 2. If you get 0.33, or this part's new, 0.66 or 0.67, that's a third or 2/3. Either one of those can be corrected by multiplying numbers by 3. Now, of course, you can have different decimals besides this. Like if you get a 0.25, that's a fourth, so we would multiply everything by 4. But either way, you have to correct any kind of fractions or decimals that you get. You should be doing a minimal amount of rounding. So let's go ahead and jump in. And again, we've already done these before. So if you want to go ahead and try this first one, you can pause the video, but I will assume that you've done that. All right, so we have ascorbic acid, which is just vitamin C, contains these percentages of carbon, hydrogen, and oxygen by mass. What is the empirical formula of ascorbic acid? So we start with our percentages and we change them to grams. So I have 40.92 grams of carbon, 4.58 grams of hydrogen, and 54.5 grams of oxygen. So my next step is I need to change them to moles, because moles is what can help me get to the subscripts. So I divide each one by its molar mass. So carbon is about 12 grams, and I'm just pulling these from the masses off the periodic table. Okay, me writing 12 or something like that for carbon should not be a mystery anymore. We've got to know where these numbers are coming from. Hydrogen, of course, has a mass of 1 gram per mole. So, of course, that number is not going to change. It will just be 4.58 moles hydrogen. And oxygen has a mass of about 16 grams per mole. So once I divide for that one, I get 3.41 moles of oxygen. All right, so these are the correct ratios, but we can't use these numbers because they have the decimals. So remember, our next step is assume the lowest subscript is a 1. And so we divide all of them by the smallest number, which in this case I have 2 of the smallest number. Both of these are 3.41. So I divide each one by the smallest number, and I should get nice whole numbers, which I don't. Now, as much as you want to round this 0.3 down to 1, you can't do that. This is like saying 1 1/3. So the way we fix that is we multiply all of them by 3. You don't just multiply the one that has the decimal by a number, you do it for all of them. So once I do that, these are my subscripts. So I have C3H4O3. And so that's my empirical formula for vitamin C. So that's my reduced formula for vitamin C. All right, so again, hopefully you're seeing this and it's jogging your memory about us doing this in honors, because we did. So let's look at the next one. So it says a 5.325 gram sample of methyl benzoate, a compound used in perfumes, contains these amounts of carbon, hydrogen, and oxygen. What is the empirical formula of the substance? Okay, so our first step is usually change percent to grams. However, they already gave me the grams, so I can just start with that. Okay, so I can start with 3.758 grams of carbon, 0.316 grams of hydrogen, and 1.251 grams of oxygen. So see, they went ahead and gave me the grams, so then I don't even have to waste time in step 1. I do still need to convert to moles, so of course 12 grams of carbon is 1 mole of carbon. And so again, y'all, the faster you get at this, the easier these become. And a lot of times you'll get to where you can do a lot of this work in the calculator. All right, so for hydrogen, of course, 1 gram equals 1 mole. So I'm going to get the same number. And then for oxygen, 16 grams equals 1 mole. And so when I do that, I get 0.078 moles of oxygen. So again, I can't use these numbers the way they are. I need to divide by the smallest. So my smallest is the 0.078. So I divide each of them by the 0.078. So I divide all of them by the smallest. So when I do that, I get about 4 moles for carbon, 4 moles for hydrogen, and 1 mole for oxygen. So since I got nice whole numbers, those are just my subscripts. So it's C4H4O, just like that. All right, so again, hopefully this is not mind-boggling for you. It could be though. Remember, we did this in honors, so you can go back to chapter 10 if you need better explanation of all of this. So, molecular formula is the actual formula of a molecule. It can be the same as the empirical formula. Not everything can be reduced. When the molecular formula is not the same, it is a whole number multiple of the empirical formula. So like P4O10 can be reduced to P2O5. H2O can't be reduced, so its molecular and empirical formula are the same. So what we're going to focus on now is how do we get from P2O5 to the P4O10? How can I figure out I need to multiply by 2? Like, do I need to multiply by 2, 3, 4? And so again, we did this in honors chem. So if you know the empirical formula and the mass of the molecular formula, then you can calculate the molecular formula. So remember, we said that whole number multiple that you're going to multiply by is the mass of the whole compound divided by just the mass of the the empirical formula. Okay, so you remember from honors chem, I used to write it's the molecular formula's mass over the empirical formula's mass. Same thing right here, it's just different wording. They used weight instead. Okay, and so I try to use lots of different wording because you never know where you're going to go in college or what textbook you're going to use. So I try to use lots of different wording so it doesn't throw you off. Alright, so let's look at our next one. And so don't forget to be trying some of these. So, acetylene, a hydrocarbon in crude oil, has an empirical formula of C3H4. The molecular weight of the substance is 121 AMU. What's the molecular formula of acetylene? So, they used AMU this time, which is fine. I can just use AMU also. Okay, so remember, my whole number multiplier is my molecular formula over my empirical formula. Well, they gave me the molecular formula, it's 121 AMU, and then they gave me the empirical formula, so I just need to add up the molar mass. So again, I'm not going to write it out because we should all know how to do this now. So when I add up C3H4, I end up getting about 40. And I'm just going to use AMU this time. It doesn't matter. Grams per mole, AMU, doesn't matter. So once I divide, I get a 3. So what does this 3 mean? It means I need to multiply the formula by 3. So it becomes C9H12, just like that. Okay, so once you get that whole number multiplier, you just multiply the empirical formula by that whole number. Okay, and again, most of you, you'll get to where you can pretty much do this whole problem in the calculator. You won't be writing anything out. I, of course, have to write everything out. Alright, so our next one, it says ethylene glycol, a substance used in antifreeze, is composed of these percentages of carbon, hydrogen, and oxygen by mass. The molar mass is 62.1 grams per mole. What's the empirical formula of ethylene glycol? Alright, well, I was given percentages, so my first step is change them to grams. So I have 38.7 grams of carbon, 9.7 grams of hydrogen, and 51.6 grams of oxygen. Alright, so my next step, of course, is to change to moles by dividing by molar mass. So 12 grams of carbon is in 1 mole. Those grams cancel. For this, I got 3.225 moles of carbon. For hydrogen, of course, it's just 1 gram per mole every single time. So hydrogen's number never changes. So if I was on the AP exam, I probably wouldn't even waste time writing out this step for hydrogen, to tell you the truth. And then oxygen, of course, is 16 grams per mole. So once I divide oxygen, I get 3.225 moles of oxygen. So remember, our next step is we got to divide by the smallest. So my smallest number is the 3.225. So I divide all of them by 3.225. So I end up getting 1 for carbon, I end up getting 3 for hydrogen, and I end up getting 1 for oxygen. So that means my empirical formula is CH3O. That is my empirical formula. Now the next question, part B, is going to ask about the molecular formula. So what I do need to remember is it has a molar mass of 62.1 grams per mole. Okay, so the molecular formula, I'm going to go ahead and write it on the board so I don't have to click back, is 62.1 grams per mole. Alright, so let's go ahead and move on because this one was empirical and molecular formula. So part B says, what's the molecular formula for the previous question? So remember, I know my whole number multiplier is the mass of my molecular formula over the mass of my empirical formula. Well, they told me the molecular formula on the previous slide is 62.1 grams per mole. So I can add up the mass of my empirical formula, CH3O, I end up getting about 31 grams per mole. So once I divide, I'm going to get about a 2. So I just multiply my empirical formula by 2, and that's going to give me C2H6O2. Just like that. All right, so this is not the answer to this question. That's the previous one. So there is my molecular formula, and I can easily reduce that to CH3O, which is the empirical formula. All right, so let's move on. So combustion analysis. Combustion analysis we may or may not have gotten to in Honors Chem. It just depends on what year you had it. So some years I make it through this, and some years I end up having to skip it. So this could possibly be a new part for you. So for combustion reactions, we can calculate the number of moles, which remember that's just our subscripts, of carbon and hydrogen from the amounts of CO2 and H2O. So we know that when we burn a hydrocarbon in oxygen, we're making CO2 and H2O. So like if I have CH4 and I burn that in oxygen, it's going to make CO2 and H2O. So as long as I know how much CO2 and H2O, I can go back and figure out what my hydrocarbon is, or how much of my hydrocarbon was present. If any other elements are present, then we can subtract that mass and get the mass of only C and H. So really the only thing we have to focus on is the fact that all of the mass of CO2 and H2O isn't coming from just the hydrocarbon, it is also bonding with oxygen in the air. So we will need to subtract that part out, but I'll show you how to do that. Okay, so this first one you probably aren't going to want to try on your own unless I got to this in Honors. So, first sample exercise. It says isopropyl alcohol, a component of rubbing alcohol, is composed of CH and O. So we know that's what it's formed from. Combustion of 0.255 grams of isopropyl alcohol produces 0.561 grams of carbon dioxide and 0.306 grams of water. Determine the empirical formula. Okay, so y'all, what I can tell is all of the carbon from carbon dioxide came from isopropyl alcohol. All of the hydrogen from water came from isopropyl alcohol. But even though some of the oxygen came from the isopropyl alcohol, some of it came from the air. So I can't just assume all the oxygen here is from isopropyl alcohol because some came from the air. So let's go ahead and start this super long problem. So the first thing I like to do is pull out how much carbon and how much hydrogen I have, because that's easy because those both have to come from the isopropyl alcohol. So I start with my 0.561 grams of CO2. Ooh, and I'll try to write small. I might have to erase in the middle of this because I have a lot of work on my paper here. Alright, so I'm trying to get to just oxygen. So the first thing I need to do is get to moles, because moles is the way, remember, we can change the substance from CO2 to just oxygen. So I need to change to moles first, so I'm going to have to use molar mass. So when I add up CO2, I get 44 grams in 1 mole. Remember, I told you I'm not going to show you how to add up molar mass every time now. We will literally never finish these videos. Once I know that, I can say, okay, well 1 mole of CO2 is 2 moles of oxygen. So see, this is like what we did in our previous video where we're pulling out one element. Alright? Whoops, I'm sorry, I'm trying to go to carbon right here, so I don't want oxygen in. So scrap that. that would be right if I was going to oxygen. I forgot I'm picking carbon. So 1 mole of CO2 is 1 mole of carbon. All right, but we're trying to get to the mass of carbon. Okay, so last step is I need to change to grams. So 1 mole of carbon is 12 grams. I just pull that from molar mass off the periodic table. So once I multiply and divide, I can see that 0.14 grams of the carbon dioxide comes from just carbon. So I know that 0.14 grams of carbon is in my isopropyl alcohol. All right, so next I can pull hydrogen from water. So I start with my 0.306 grams of water. So first step is, of course, I need to get to moles, so I can change from water to just hydrogen. So molar mass of water is 18 grams. That's just me adding up H2O. That equals 1 mole. Next step is I need to pull out just the hydrogen. Let me pull out the right element this time. So 1 mole of water is 2 moles of hydrogen. And then last step, of course, is to get to the mass. So 1 mole of hydrogen is 1 gram. That's just the molar mass. So once I multiply and divide for hydrogen, I end up getting 0.034 grams of hydrogen. So what that means is 0.14 grams of my sample is carbon, 0.034 grams is hydrogen. So the rest of it has to be oxygen. So this is where you have to be careful. You don't want to try to just subtract these numbers from these amounts to get your oxygen, because then you're also including the oxygen from the air. Remember, we don't want the oxygen from the air. That's not in the isopropyl alcohol. Okay, but if you notice, they gave us the amount of isopropyl alcohol we're starting with. So if I know this much is carbon and this much is hydrogen, the rest of it has to be oxygen. So I take my 0.255 grams of my sample, and I just subtract the carbon, which is 0.14 grams, and I subtract the hydrogen, which is 0.3034 grams. So I'm just subtracting the carbon and hydrogen because I know what's left has to be the oxygen, because they told me it only has CH and O. So once I subtract, I end up getting 0.068 grams of oxygen. All right, now, already this was a lot, but surprisingly, we are not even at the end yet. Now we're at a normal empirical formula problem. So instead of starting with percentages, I have started with grams. So I'll try to continue this way. Hopefully I don't run out of room. But these are super long problems. So now you'll see why, if I did skip this when you had me for honors chem, you'll understand why. All right, so remember, I have grams, so my first step is to change it to moles. So I do my 12 grams of carbon on bottom. And so for that, I end up getting 0.01275 moles carbon. Ooh, I went out a lot of decimal places for some reason. All right, for hydrogen, of course, we know 1 gram is 1 mole. So it's going to stay the same. Whoop, this should be moles. Sorry about that. And then for oxygen, we know 16 grams is 1 mole. Whoop, cancel out all my units. And for that one, I got 0.00425 moles of oxygen. Ooh, went out a lot of decimal places there too. So I divide by the smallest, which is the 0.00425. So I divide each of them by the 0.00425. All right, and so see, now it's just a normal empirical formula problem. So I get 3 moles for C, I get 8 moles for H, and I get 1 mole for O. So it says, what's the empirical formula? Ooh, I'm out of room. So it's C3H8O, just like that. Okay, so again, since this could be new, let me just recap real quick. Okay, so all we did was we started with our amount of CO2 and we converted to figure out just how much is carbon. Then we started with our amount of H2O and we converted to figure out how much is just hydrogen. Then we took those amounts and subtracted from the sample to figure out how much oxygen we had. Once we do that and we have the grams of each of our element, then we can do a normal empirical formula problem where you change to moles, divide by the smallest, so forth and so on. Okay, so now that you saw me do one, definitely make sure you try the next one. Okay, you can even pause the video and then, just work out part of it and stop the video, play it, to make sure you're on the right track. But I will also try to fit this one all on the same board. We'll see how it goes. Again, it's very long. All right, so we have Proprioc Acid, the smell in dirty socks. Well, there we go. That's interesting. It's composed of CH and O atoms. The combustion of a 0.225 gram sample of this compound produces this much carbon dioxide and this much water. What's the empirical formula? Okay, so the first thing I'm going to do is try to pull only the carbon out of the carbon dioxide. Okay, so I'm going to try to write a little bit smaller this time so I have more room. So I have 0.512 grams of carbon dioxide. So first step is I need to get it to moles. So there's 44 grams of carbon dioxide in 1 mole. Next step is, of course, change it to just carbon. So 1 mole of carbon dioxide produces 1 mole of carbon. Next step is get to mass of carbon. 1 mole of carbon is 12 grams of carbon. So once I do that, I ended up getting 0.14 grams of carbon, just like that. All right, so next I'm going to try to pull my hydrogen out of water. So I start with my 0.209 grams of water. First step is change it to moles. So 18 grams of H2O, that's just the molar mass, equals 1 mole of H2O. Now I need to change it to just hydrogen. So 1 mole of H2O makes 2 moles of hydrogen because hydrogen has a subscript of 2. And now I need to change it to grams. So 1 mole of hydrogen is 1 gram. So once I multiply and divide all of that, I get 0.023 grams of hydrogen. Okay, so now I know my carbon, I know my hydrogen, so last step is I need to subtract it from the sample to get the oxygen. Remember, you can't subtract it from these amounts because the carbon dioxide and water also have oxygen from the air. So I take my sample, which is 0.225 grams, and I subtract my carbon, which is 0.14 grams, and I subtract my hydrogen, which is 0.023 grams. And that'll give me how much oxygen. So when I subtract, I get 0.062 grams of oxygen. Oops, sorry, my O got kind of weird there. Okay, so now that I've made it to this point, I can do a normal empirical formula problem. So I have my grams already, so I don't have to waste time with percent to grams. So I say, okay, well, 12 grams of carbon is 1 mole. So once I do that, I end up getting 0.0117 moles of carbon. All right, I know that for hydrogen, 1 gram is 1 mole. So of course that number is not going to change. It never does. Whoops, that should be moles. And then last step is, of course, 16 grams of oxygen is 1 mole oxygen. And so once I divide, I get 0.0039. Alright, so once I got back to moles, now I need to divide by the smallest. So my smallest is the 0.0039. So I divide each of them by the 0.0039. Whoops, that was a 6. And so what I got was 3 moles for carbon, I got 6 moles for hydrogen, and I got 1 mole for oxygen. So once I know this, I know my empirical formula is C3H6O, just like that. Okay, so like I said, combustion analysis could be new for you. It just depends on whether or not we got to it in honors chemistry or not. All right, I'm going to leave this up here because I know there's a part B, and I think we need our empirical formula for that, but I am going to erase the rest of it. Okay, so y'all, and all the combustion analysis works the same. Okay, you just have to make sure that you take into account that some of the oxygen is not coming from the hydrocarbon itself or the alcohol or whatever it is. It may be coming from, it is coming from the air. So it says Proprioc acid has a molecular mass of 116 grams per mole. What's the molecular formula? Okay, so we know we need to do that whole number multiplier, and we know it's the mass of the molecular formula over the empirical. So they told me the molecular formula is 116 grams per mole, and I calculated the empirical formula from the previous question. All Alright, so once I add up the mass of this, I get about 58 grams per mole. So once I divide, I end up getting a 2. So then I just multiply my empirical formula by 2. And so I end up with C6H12O2 as my molecular formula. Okay, so let me erase this. This was the empirical formula from part A. Alright, so hopefully the beginning of this video was just review. Like I said, the only new part that could have happened was this combustion analysis. Okay, but still is similar to what we've done before. So hopefully it wasn't too difficult.